Okay, so welcome to week 10 in Math 225 at Delta. And today we're going to look at a little bit of the dates and times features in chapter 16, and those will be integrated into an exploration of three data sets. One data set, the train accident data set, is one that we've already investigated a little bit. And there's going to be two new ones, and one is going to be related to dogs, adoptable dogs, a listing of all of the adoptable dogs in 2019 in the United States. And then the second one is related to all of the traffic tickets that were given by the Gratiot County Sheriff's Department. And that county is just a little bit west of us. So install the usual packages, the IDverse package. We're going to be using the maps package and this SF package. If you want to know more about those, you can put the double question mark ahead and run those lines to see what those packages look like in the output screen. So load up all of the different packages and then import these three data files. These are the three that we're going to be using in this presentation. Now, the first data set is a data set where we look at 3,000 tickets given by the Gratiot County Sheriff's Department in 2017. So here's a look at Gratiot County, Michigan. Here's the state of Michigan, and Gratiot County is right there in the middle of the state. It's right next to Saginaw County, and it's a little bit southwest of Bay and immediately southwest of Midland County. So right in our area. If you're going from Midland down anywhere into the southwestern part of the United States, if you drive from Midland, you really have to zigzag through this county in order to get to one of the main highways taking you down. So this is what the rectangular county looks like. You'll notice three blue stars here. These are the local police departments. And then you have the red star here. This is the location of the sheriff's department. There are 83 counties in Michigan, and each one of them has their own sheriff's department. And I think that's uniform, throughout the country. There's a lot of different sheriff's department. They monitor the counties. And one of the things they do, in addition to enforcing laws, is they also patrol the roads. And that's one of the main features of the sheriff's department, is to monitor the county roads. The police officers of a sheriff's department are known as deputies. So the original idea for this data set was to try to figure out what is the best way to go from Midland through Gratiot County on our way to the southwest to avoid all of the speed traps. And so this data here consists of all of the traffic tickets that were given in Gratiot County in 2017. When police officers stop a car for a traffic violation, sometimes they find that there are other offenses as well, maybe a DUI, or maybe a marijuana use, or it could be that the person in the car doesn't have insurance, doesn't have the correct registration for the car, or doesn't have a correct driver's license. And all of those can be ticketed as well. So all of these stops start with a traffic stop usually, and then they could potentially give more tickets after that. So we're going to investigate all of those 3,000 tickets. Okay, so the first thing we're going to do is to read in the tickets, and we'll just assign it to X, so we don't have to type in tickets all the time. Let's just take a look at the dimensions. So you can see that there were 3,133 tickets. There are 10 different columns, and if you want to take a look at the head, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different fields. They all fit right on one screen here. The state and county are not interesting because the state is always Michigan and the county is always Gratiot. You have what is the infraction title. This is an internal. What is the infraction number? This is the officer's name, and we have the longitude and longitude numbers. The location. Now, the location that they give is always the corner of, it's an intersection. So wherever the ticket is given, they identify the closest intersection, and that's what the latitude and longitude are related to this location. Type of ticket, whether it's a traffic ticket or a civil infraction or a misdemeanor. When the date was, notice the format of the date. We have month first, and then day, and then all of these years are 2017. And this is the ticket number. When you see something in parentheses here, that means that there was another ticket on this same ticket number that was awarded to the driver during the stop. All right, so what we want to do in our first problem here is just create a map plot of all of the tickets using the latitude and longitude fields. So what we're gonna do in this problem is just play around with the scales. And so these are the latitude and longitude scales so that we can zoom in on a particular county in Michigan. So again, let's take a glimpse at this. These are the variables. So the first thing we're going to do is to revisit our map. Let me enlarge this a little bit. All right, we're going to investigate our standard map. And so this first one with these markings along the X and the Y axis will give us the entire map of the United States with state borders. Now notice that I brought in this data set X here. This is their listing of all of the tickets and their latitudes and longitudes. And notice we are going to plot the longitudes and the latitude points. So this is a map. Notice that this regional value is state. So that's why we're going to get the state borders. And then we just draw a quick map. We can label the X and the Y, and then make sure that we have our latitude and longitude numbers zoomed in. Now you can see here is all of the tickets right there in the middle. All of the 3,100 and so tickets were plotted right there. And it looks like there's a couple tickets down here. Now in the next one, I'm going to filter out those ones down under these over here, because these obviously are not tickets that were awarded in Gratiot County. And so if I just change this latitude so it goes above 43.1, it'll wipe out those there. And that's what the intent of this next one is. Now we can also create county borders. And all you have to do is say borders equals county. And pretty much everything else is the same. But what I've done here is I've reduced these numbers so that we're only going to see Michigan. And there it is, and you can see the county borders. And I got rid of these points down here as well. It may have been the case that, one of the officers had to, travel down here to pick up a prisoner or something, and they stopped somebody along the way. I'm not sure exactly what happens, but usually the sheriffs only have jurisdiction in their own counties. All right, so for this next one, all you have to do to zoom in on a different county is just to change the latitude and longitude numbers. And so that's what I'm going to do here. You can see if we go from 84 to 85, then we pretty much will capture this county. You can see here I'm going from negative 86 to negative 83. So I'm going to capture from here to here. So it's going to be the middle counties. And then on the latitude, we're going from 42.3, which is about right here, up to 44.5, which is right here. So we're going to kind of focus in on this area here. And this is what it would look like. All right, so try a couple of views. You can see maybe what you have to zoom in on here and what you have to zoom in on here in order to get only Gratiot County. All right, let's take another glimpse. And you'll notice that for the date, the issue date here, that the date is in the format of a 2-digit month, a 2-digit day, and a 2-digit year. All right, so I want to go through and take a look at a date like this and some other dates and just convert them to another format. Chapter 16 gives you a lot of information about the changing dates from one format to the next. But let's say that our date is in this format, and where the middle number is the month and the number to the left is the day, and the number over here is the year. All right, so the first thing we're going to do is to assign our date format to be X. And let's take a glimpse at that X. Notice it just replaced. It thinks it's a character, so it's not interpreting it as a date. Because we want 9/11 here, September 11, 2001, the middle number here is the month, and the first number is the day. So that's why we go day, month, year. A lot of times if you do this, it'll just be able to convert it. And so let's see what happens. Well, it changed it from this format to this format. We've got the year first, and then we've got the month, and then we've got a day. The question is are interpreting the month to be the month, the year to be the year, and the day to be the day. So let's just use this month command, and it's thinking that the month is 9. That's good. It's thinking of the day is 20. That's not good. We want the day to be 11. And then when we go to the weekday, it's telling us that the weekday is day number 3. Now, day number 3, the days start with Sunday is 0. No, Sunday is 1, and Monday is 2, and Tuesday is 3. So this is Tuesday. And then the year, it thinks the year is 11, which appears to be the first number up here. So it's not interpreting these dates the way we want them to. So let's try again. Let's bring in our X, and now let's change it to date, month, and year. But then let's reassign X, because we broke apart the DMY, but we didn't reassign it back to X. So what we're going to do is we're going to take that format and we're going to change it back into the same format as you saw up here. But because we did this and reassigned X to be X with this format, when we now recall the month, it says month is 9, that's good. Day is 11, that's good. Now notice these commands up here. If you insert them in next to weekday, this is what happens. You turn the label to true. So that's going to give you, instead of the number, it's going to give you the spelled out version. And if you want the abbreviation to be false, it's not going to give you the abbreviation of the weekday. It's going to give you the full word. And we want to see the full word. So let's see what happens there. And notice it says that the day is Tuesday. If you didn't have the abbreviation part in there and ran this, then you could see that it's just going to give you 2, TUE. And then when we look at the year, you can see that it got it right, 2001. All right, so we do now have our X. It's just one date, and you'd have to update this for all the dates if you wanted to change all the dates to this format in a data frame. All right, so now we want to change that date to this format here. So once again, let's take a look, and you can see that the date is in this format here. And we know that it's interpreting the year is the year, the month is the month, and the day is the day. All right, so here's what you have to do. We're just going to use a command from the string section, and we're just going to paste a bunch of pieces together. So if you look at the format of this date, in the quotes here, we have the abbreviation of the day, followed by a period, followed by a comma, followed by a space, and then we've got the full name of the month, and then a space, and then the day, and then a comma, and then a space, and then a year. So we have to paste all of those pieces together in using the paste function. And at the end, since we're going to put in our spaces in between, we're just going to say the separator will just be nothing. This is a quote, nothing between, and another quote. Here is the first part where we want to just give the weekday. And notice we have label equals true, so it gives us the wording, but we don't have the abbreviation equals false, so it's just going to give us the abbreviated name of the weekday. Then we have the period, put the period after, and so this whole piece in here in quotes will come next. So after 2, you get the period, and then the comma, and then the space. And then here, we want to list the month. We want the full spelled out name of the month. So we want label equals true and abbreviation equals false. Then after the month, we want just one space. So we put that in between the quotes. And then we want the day. The day, we won't say label equals true, abbreviation equals false, because it's just the day. It's a number from 1 to 31. There's no alternative version. They're not going to spell out the word 1, for example, because we never do that in a date. And then after the 1, again, we want to put a comma and then a space, and then we want the year. And for the year, that also is a number that we're not going to spell out in any way. And then finally, just say that since we put in all of our formatting up here, we're just going to let the separator be nothing. So this is what the new date would look like, and you can see it matches our format perfectly. In the next conversion from one date to the next, we're going to do this one here. Now, this one gives month, day, and year instead of day, month, and year. And so that's why down here, I'm going to use month, day, and year. And I'm going to break it down so it gives me the new format, and then I'm going to let X be that. And then I want to convert it to the full name of the day, the full name of the month, the day without a year listed. All right, so here is our assignment to our new X. Let's take a look at it. There it is, same one. And now we're going to convert it. And let's take a look at what the new conversion looks like. There it is, year and the month and the day. But now we have to make sure that it's interpreting things correctly. So is the month 9 and the day 11 and the weekday Tuesday, yep, and the year 2001. Okay, so everything's in the right format. And then here is the way that you would create, using the paste function, the new date. You got the weekday spelled out, Tuesday. Then you've got a comma. There's no period needed here because we have the full spelled out name of the day. And then we have the full spelled out name of the month, followed by a space. And then we've got the day, and notice there's no year after that. So if we run this, you can see we've got the format the way we like it. Now, it's okay if you parse these dates together because the point of this is just to create a new date. Yeah, we could go ahead and create a new variable that has this text date to it. And we probably wouldn't use this field afterwards, but we could. Okay, in the next example, we're going to convert from September 11, 2001 to just 9/11. And so I'm going to let X be our new date. Let's take a look at it. There it is. It thinks it's a character. We do know that month comes first, and then day, then year. So let's use the month, day, year, and then of this number here, and then let's convert it into the new X. And let's take a look at that date, that new date, and there it is. We've got the year, the month, and the day in our standard format. Let's see if it's interpreting correctly. The month is 9, the day is 11, the weekday is full spelled out Tuesday, and the year is 2001. Now for this one, all we have to do is just paste the month, and then this in quotes, the slash sign, and then the day. And separator is none. And there it is, 9/11. Now, if you don't put this separator in here to be nothing, and you run this, then you'll see that it has these gaps in 9/11. So you don't want the gaps, and so you want to leave in this separator equals nothing. So those are 3 different dates and how you can convert them from the form it's given to into a different format. We're going to return to the tickets data, and in this problem here, we're going to define the Ithaca officers. Now, the Ithaca is the county seat in Gratiot County, and some officers patrol only that local area. And it turns out that these 4 officers here are the ones that patrol the middle of the county where the county seat is, Ithaca. And we're going to determine if a higher average number of tickets is given by the Ithaca officers as opposed to all of the other officers whose main responsibility is to patrol roads outside of Ithaca. And we're going to display the number of monthly, yearly, and weekly tickets, or maybe daily tickets, given by these officers. And we'll compare the Ithaca officers to the non-Ithaca officers. And we want to know, is there evidence that there are more tickets given by the non-Ithaca officers? All right, so we have to redefine the X because we've been using it for dates above. And we're going to go back and redefine it to be our tickets data site. And once again, we'll filter out those lower values. And then let's take a glimpse. All right, so there is our full data set. We have 3,000 rows. All right, so I'm going to define this filter, and in this first one, just to show you where these 4 officers patrol, I'm going to do another quick map. Here it is. These 4 officers primarily patrol right here in the middle. This is Ithaca. You can see that those 4 officers also maybe went up a little bit higher in the county at some point during the year and awarded a ticket as well. All right, and now what we're going to do is we're going to add this new variable, Ithaca officers, and we want it to be, if the officer is one of these 4, we just want to assign the logical value true, because that means it's one of those Ithaca officers. And if it's not one of the Ithaca officers, then we want it to be false. So this creates 2 different groups, the Ithaca officers and the non-Ithaca officers. All right, and then if we do a table of the Ithaca officers, remember in that variable, there's only trues and falses. And you can see that of our over 3,000 tickets, 93 were given by our Ithaca officers, presumably in the town of Ithaca, and most of the other ones were given at other parts in the county. Now this next blurb, we're going to mutate 3 variables, call them the yearly average, the monthly average, and the daily average. And we're going to separate by Ithaca officers. So we're going to have a grouping of all the Ithaca officers and then a grouping of all the non-Ithaca officers, and we're going to count the number of tickets of each kind. Now, once we get those counts, we're going to use them to calculate the yearly number of tickets per officer given per year, and then the number of tickets per officer given per month, and then the number of tickets approximately given per day by the officers. And then you can say we're going to arrange by count. So let's see what happens when we do this. And there is our table. You can see the variables in the table. The first one is the one we group by. The next one is the count. The next one is the yearly average, then monthly average, then daily average. Everything that's mutated is also going to go to the display table. And then we're going to arrange by count. So you can see there's just here, we really don't need that one here. It's clear that there are going to be more non-Ithaca officers than Ithaca officers. But here we have it. Are you an Ithaca officer? False. So these are the non-Ithaca officers. They give this many tickets per year. They give this many tickets per officer because there are 18 different officers that are not patrolling Ithaca. And then if you divide that by 12, this is the number of tickets per officer given each month. So they don't even give a ticket by officer. They give 13 per month per officer. So that's not even 1 per day. And if you look at the number of tickets per officer they give each day, it's less than a half ticket. So it's not like there's an officer out there, giving 15 tickets a day. It just doesn't happen. And for those that work in Ithaca, you can see they have many more responsibilities in Ithaca because they only give 93 tickets in the town of Ithaca throughout the year. And this works out to 23 tickets per officer. And this means 1.94 tickets per officer per month. So it's about two tickets per officer per month. So that's not a major amount of tickets given. And if you look at the number of tickets per officer per day, well, it's just a tiny number. So this is probably a benchmark we can use, that the Ithaca County officers award about 2 tickets per month per officer. And you can see that for the non-Ithaca officers, they award about 14 tickets per officer per month. So they're a little bit more active, and that works out to about 1 ticket every 2 days is what they give. And it might be the case that they give, 5 tickets one day and then no tickets for a couple days and so on. They've got other things they need to do as well. So sometimes traffic stops result in additional tickets. And one of those additional tickets is the no proof of insurance. If you don't have proof of insurance, you get a ticket. Or if you don't have your proof of insurance, you get a ticket. And then maybe they'll allow you to waive that ticket if you go to the court and show that you do in fact have insurance. All right, let's take a look at the tickets again. And you can see that right down here under the infraction, that's the variable that we're interested in. And then here's the very first one. This is just one of many different possible citations that can be received. So what we're interested in here is just to filter out by only those infractions. And then we're going to group by officer, count up the officers that give this kind of ticket. And then we're going to arrange them in decreasing order. All right, and then this is what it would look like. So we can see here that there are 22, And it looks like all of them, because there are 22 officers total, it looks like all of them give this kind of ticket. But Aurelio Lopez gives the most, followed by Al Cowens and Denny McLean. This is probably related to the number of ticket stops. So if you have more ticket stops, you're going to have more tickets given for failure to produce insurance. Okay, in this final problem, we're going to revisit the train accidents, and we're going to look at train accidents from one particular county in Michigan. Bring in the train accidents data. This is what it looks like. The dimensions, there it is, those 84,000 train accidents. And remember, those are the variables. All right, the first thing we're going to do is to create a map plot displaying all of the train accidents in Saginaw County. So that's going to involve changing the latitude and longitude numbers. And we've zoomed right in. So they got these funny borders when you select them, so you can just ignore that. Ignore these diagonal pieces generally. So this piece that goes up around, that's not really part of the county. The accidents in Saginaw County are these right here. So if you really wanted to, you could just zoom in on these longitude markers and these latitude markers to get all of those. In this next problem, we want to convert the fields that are available to year, month, day. And so let's take a look at Y. And if you scroll all the way up to the top, you can see that we have one variable here that corresponds to the 2-digit year. We have one variable here that corresponds to the month. And you go down further, you see year is a 2-digit year, month is a number, day is a number, and we also have time in minutes and the AM, PM. You'll also notice that there's another variable down here called year 4, which gives the 4-digit year, and that might be useful here because we're looking for a 4-digit year. All right, so we're going to select month and day, which I believe is, well, let's see if it's in caps. Nope, day doesn't exist, so day is in caps, and there you see it. So we basically want to put together the month, the day, and the year first, and then month, and then day. So we do that with our paste command, and you can see that when we look at them all, it's going to give us the correct format. Year first, then month, then day. However, we have this 1-digit month in the middle, and we want to change that so that all of the months are 2-digit. So a 4 would be a 04 instead. So I'm going to run this year, month, day command and reassign that to the new date field, new date 3. And then when we take a look at it, notice that now the 1-digit dates are now 2 digits. And the last one here, we're going to create a report called the Saginaw Train Accident Report. It's going to contain the date in this format here, and it's going to identify the responsible railroad. It's going to give us a cause as listed in the category column, and then we're going to report the first narrative. So the first thing we're going to do is to take a glimpse just to see that, those are the fields we're after. We don't want this big narrative here, but we want just the first narrative. We're going to filter these latitudes and longitudes so that we get only the accidents in Saginaw County. So we want to go somewhere between, say, here, which is -84 and some change, and over here, this is maybe 84, 83.8 or something in here. So in here, and then on the latitude markings, we want to go from about right here up to about right here. And these numbers do it. And then we're going to print off, we're going to select the fields, the date, the railroad company, the cause, and then the narrative. You can see we have all the relevant information, the date in the format we want it. Notice that there's just 2 railroad companies operating in Saginaw, LSRC and HESR. And here were the causes. Sometimes the wheels get too heated up. The track geometry, one of the rails will get skewed or bowed or something. You've got switches. Sometimes the use of switches causes the accident. And then over here is the first narrative. And the final thing you want to do is to write that file and save it. And you can send that report off to the local media or Chamber of Commerce or whoever might be interested in it. Good luck working with dates in these 3 data sets this week.